morning, good afternoon, whatever time zone you're in. Welcome to another Arctiq Backstage Pass. My name is Aaron. I'll be your host for today. And today we're going to do a focus on something a little different and might be even a little bit new for some of you. It's called Apigee Hybrid on Google Cloud. And we're going to have a slew of presentations on this. We're going to cover a range of topics from architecture to even context around deployment. And we're also going to get a special guest at the end. So let's dive right in. So how this is going to work today, we're going to go over who is a short of who is Arctiq and our relationship with Google Cloud and Apigee. We're going to go through that introduction, a quick intro on Apigee. So we will get into our technical presentations and demos with as much real-time Q&A as we can fit in, given that we have a number of things to go over today. We'll do the remaining Q&A, which, by the way, we're going to do through our YouTube chat. We have special guest, and then we will wrap up. So today, to engage with us, please jump in on social media with our usual channels. You can find them at arctic.ca. Otherwise, the majority of you should be watching us through YouTube Live, so use the chat window to the right and we'll see your questions. What I'll try to do is bring them in, if possible, during the presentation, but otherwise, we'll bring them in near the end during our dedicated Q&A session. So let's get right into it. We have Google Cloud, Apigee, and Anthos, so combining the powers, so to speak. Arctiq already has a relationship as a premier partner with Google Cloud, and we've had a lot of work that has gone into, and we've invested a lot of time into Anthos and everything around it in our ecosystem. So now with the introduction of Apigee, which, if you look into the articles and in the news, we know that Apigee was acquired by Google in 2016. With Anthos released by Google in 2019, I think there just needed to be a bit of time for everything to ramp in and align the stars, so to speak, to get Apigee to be workable on Anthos this year. And our presenters will get into the details about how and why that happens to be the thing. And now today we're kind of focusing on Apigee Hybrid, which brings us to most of the other clouds and everything that comes with it. So what is Apigee? It's a pretty deep topic, and like a lot of things that are involved with Kubernetes, there's a lot of abstract concepts as well. But essentially, today, if you run a public-facing or even an internal-facing API, you might want to put something like an API proxy or API gateway in front of that API to give you a number of benefits. So the proxy layer in front of your API services is one thing, and you can imagine what that might get you on top of that. I won't go too much in depth, that's for our presenters to do today. But essentially, it provides sort of a facade for your backend service APIs. What you want to kind of aim for is your quick gains like a security layer or rate limiting quotas or analytics for your exposed APIs. And it's become an item of interest with a number of our customers that happen to be exposing either internal or external APIs. So trying to get a quick concept of what just an API gateway is, this is kind of a good graphic to show you what the relationship between the components might be. So on the left, you've got, our clients or us, the customers or consumers, interact directly with the API gateway, and that gateway is where Apigee falls into place. And the other piece is along the top here and the bottom here are the other sort of, you could call them almost plugins or modules that we add on as layers to the gateway before it presents anything in the target API. There's a lot more to this. This is a very simplified diagram, and I know we'll get into more detail as this event goes on. So more focus on Apigee specifically, this gives you a better idea of an example of some of the actual things that you might be doing with it as an API gateway. So there's the consumption side and the exposure side, and the management platform sits in the middle, kind of as a broker for some of the things that the clients interact with on the back end, with Apigee in the middle. So what is Apigee Hybrid? Now, Apigee itself can be deployed as just a product, and as a platform, you think of it as a platform for developing and managing API proxies, and that's just how it can be used without the hybrid piece. Now, if we introduce the hybrid piece, this is about separating the management plane from the runtime plane. The runtime plane is what you can run on your own Kubernetes, and the management plane is what remains inside Google Cloud, hosted by Apigee. So um, there's a lot more to these layers, as I said, but that second piece there at the bottom is what makes up the hybrid that we're most concerned with today. And let's continue. So today, let me introduce you to our speakers, and I'll start with, of course, the first. We can't have them all at once. We can't multitask that well. But we're going to start with Apigee across multi-cloud with Leo. Then we'll move on to visual tracing and debugging with Greg, and then Apigee Hybrid Autoscaling with Aurora. So we have a lot to get to. I'm going to try to get to them as soon as possible now. So we'll start with Leo. Hey, Leo, how you doing? You're muted. It's okay.
Hi, Aaron, and hi, everybody. I'm Leo. I work at Arctiq as a consultant, and I work focus on microservice architectures and cloud architectures for our customers. And today I'll be speaking about the overall architecture of Apigee. As Aaron mentioned, there is a management plane and a runtime plane. But let's take a step back before we get there and talk about what it necessarily caused this product to be to exist. What's the need for this product? There have been two prevailing trends in how enterprises are operating. The first one is APIs, which if someone doesn't know on this call doesn't know what an API is, they're essentially the communication contracts between business groups and entities, how their systems communicate with each other, are becoming more and more ubiquitous. A lot more systems are talking to each other. And number two is enterprises are expanding outside of their data centers with workloads that span across multiple clouds. So you no longer can use just a single SaaS-based API management solution that's centralized. You need something that spans out just like the way your APIs and your data center and cloud workloads are doing. So as this more and more of, first of all, this trend is becoming a reality. So you'll see this more and more prevalent everywhere. And as the scale of these APIs increase and the workloads increase, so does the complexity and the operational management, as well as the human communication management. Hey, what is this? Where can I access it? Where is the API access key for this? And so forth. You get that over email, Slack, or any other communication platform. So there's lots of noise and congestion that happens as well. There's also ensuring a set of particular standards for development and security practices that you want to always have in front of your APIs. And as you're developing thousands and thousands of APIs, it becomes much more harder to make sure everyone checked off all those boxes. So this is where Apigee Hybrid comes in. Apigee Hybrid gives us an ease, the breadth, and the reliability of a mature SaaS offering with the deployment flexibility of a true multi-cloud offering. And as Aaron introduced in the introduction, we have Apigee Hybrid comes with two planes. There's a management plane, which is being hosted on GCP, and you can access that by going to apigee.google.com. And this is where your API developers can manage the different API settings and their environments and so forth, which we'll get into. And then on your multi-clouds or on your own data center, you're running Kubernetes, and there's a runtime for Kubernetes, which is the runtime plane in Apigee. And you can deploy this on any of your clusters, and you'll have an Istio gateway in all of those clusters, and your clients will directly interact with your gateways right there. The benefits you get from this are because the gateways are being hosted on your side, all the API traffic that happens is happening on your side. There's nothing going across the cloud to some particular different outside of your, for example, governance zone and so forth. And your data stays within your network. And as far as the management plane, it gives you a lot of capabilities like API security and policies, analytics and reporting for your business units that want to know how many developers are accessing our API or what are the trends that are going on with our different APIs. You'll have a single source of truth for all the access and documentation. So there's no more 50 different emails asking the same question of where is the key, how do I access this environment, and so forth. And you get that through the self-service developer portal. You also get productization, and you'll have the option to monetize these data and services that you produce. As far as the Kubernetes runtime that I was mentioning that you run on each and every one of your Kubernetes clusters, there are a couple of components, but these are the four main ones. We start off with the message processor. This runs as a replica set, and it basically handles all the API requests to your services and also manages any policy executions that need to happen. It's scoped within a single environment, and I'll get into what environments are. Think of them as like sandboxes. And it's very resilient to connectivity outages. And then you're rolling updates that happen from the management plane, basically, you get across as rolling updates in the Kubernetes cluster, and it updates the message processor. The entire data is stored internally on your own data centers in each of your clusters in a Cassandra database. And Apigee uses a Cassandra operator. It's persisted on your data center, and it basically stores all the API products, keys, tokens, cache, but none of the analytic stuff. That stuff is shipped out back to the cloud. And it also has cross-cloud backup, so you can back up your database automatically to S3, GCS, or anywhere else you like. The next component is the synchronizer. So the synchronizer operates on a schedule. I think by default it's 60 seconds, but it can be changed. And it replicates all the artifacts that you create on the management plane, and it brings it across into your cluster, so your cluster always knows what's going on. And then finally, we have MART, which stands for Management APIs for Runtime. And that exposes an endpoint that helps the management plane be able to talk to your runtime API and be able to administer different APIs, keys, tokens, and so forth. This is also scoped within a single organization. When you're setting up your hybrid, Apigee Hybrid, you set up an organization, and it has multiple different environments that you can run different proxies in. And I'll get into more details on that. From a multi-cloud architecture level, today's presentation, we've set up two different clusters. One is in GCP and one is in AWS. The GCP one is in North America, and the AWS cluster is the GKE in AWS cluster is being run outside of Europe. And as you can see, we have all our different components that make up Apigee, and there's a Cassandra cluster that's connected to each other. In the event that there is a network loss of connectivity, and your synchronizer or your MART cannot connect to the management plane, they still have the latest version of the last good sync of information as far as all the proxies, the keys, and so forth. So even if your cloud connection to the management plane is disconnected or disrupted, the clients that are accessing your APIs will still go through your normal gateways, and you won't have any failures, and you'll be able to meet your SLOs and SLAs. It's also important to mention that Cassandra here is connected, so it's sharing the information. And if you have a quota set up, you can have a multi-region quota on your APIs, and this will all be synced over. As far as environments are concerned, think of them as sandboxes that you can create for each and every one of your APIs, and you can put them, so you can have one domain that has different API paths into different environments. You can split this between prod 1, QA, dev, or for different business units. This helps isolate your proxies and helps you basically have some form of control and do basic RBAC on top of it. So you can say, this group of developers can only access this environment, and they can only do certain features on here and so forth. And for example, pen testers can access this particular environment. So it's kind of like partitioning your different proxies and the different versions, and it really helps you organize as you have these different services which are running the same proxy but like in a different flavor and a different version. Before we continue, I know this is a talk about Apigee, but you can't really talk about Apigee without talking about Anthos. Anthos, I'll give a quick overview of Anthos, is a platform Google has provided and developed, which basically allows you to manage all your Kubernetes clusters across different clouds and on your on-premise data center from a single pane of glass. You can have Anthos running on AWS, Azure, and when I say you can run Anthos, I'm essentially talking about you can run Google's GKE version of Kubernetes on AWS, on Azure, or on VMware or bare metal. And Apigee Hybrid ties beautifully into this, because not only are you sprawling all your APIs and all your clouds through this multi-cloud way, and if Apigee is helping you see them all in one place and manage them in one place, Anthos also works very well as a complement to be able to help manage all your clusters all in one place. So together, they make a very good complement, as I said. So let me switch over to my demo, and I'll briefly talk about how this all looks. 1 second. So here is my AWS control panel. And here we are in Frankfurt, EU Central 1. We're running a version of GKE on AWS in this region. And this communicates back to the Anthos hub. And we can see this and manage this entire cluster, Kubernetes cluster, in GCP. And here we have our AWS cluster, and here we have a secondary cluster, our GCP cluster. You can see it says provider AWS here. And with Anthos, you can easily see all the different workloads, services, all in one pane of glass, and all the different applications that are running. So let's first look at all the different workloads. Here, here you can obviously switch.
Leo,
yes.
I just want to make sure you're showing what you intended to. So right now we still just see the AWS screen.
Oh, I'm so sorry. Let me fix this. Thank you for bringing that to my attention. Demo.
Absolutely.
This should do it. Are you able to see AWS and GCP?
Yep, that looks good.
Okay, sorry everyone. So again, this was AWS where we had a GKE on AWS cluster running. And here is that same cluster running on GCP. In addition to our secondary GCP cluster. And this is how basically Anthos allows you to register your different clusters and be able to manage them from a single pane of glass. You'll be able to see all their workloads and all the different services all in one place, and you can get logging and monitoring all in one place. As I was mentioning, regarding the different components, you'll see them here running as different services. In addition, I said there were a couple of other ones. For example, you can see the metrics server here. That's essentially, there's a packaging of Prometheus and FluentD, which sends all the metrics back to the cloud for statistics. But you can also connect that to your own telemetry systems or your analytics systems as well. What I'd like to draw your attention towards is the Cassandra cluster. Here we're running in our GCP cluster and in our AWS cluster, 3 nodes for Cassandra in each. And let's open up Cloud Shell. Give me a second, reconnect. Okay, great. So if I describe my clusters, if I'm describing my Cassandra nodes, you'll see that I have 6 Cassandra nodes, but 1 cluster that's managing it basically across the 2 different regions. And if we look at status of these, we'll see that in data center 1, we have these 3 nodes, and in data center 2, we have these 3 nodes. So essentially, the Cassandra nodes are talking to each other, and we have all these Cassandra rings operating beautifully. And if we go into the Cassandra nodes, and you can see all the data, everything is here, everything is synced between the 2 different clusters across the region. The big takeaway here is the ease of use and the overall control that you get across your APIs. And as you're developing even internal APIs right now, tomorrow you could come into work and a product manager or an executive can say, that's a great API, we need it for this particular purpose, and all of a sudden you have to externalize it. And all that extra work that you have to do to be able to make it ready to be consumed from an external perspective, Apigee will help handle all of that for you and make that friction far less and the toil far less. So that's kind of the overall architecture that I wanted to show today. I'm going to pass it back over to Aaron, and he'll introduce our next speaker.
All right, so thanks, Leo. That was a great presentation. We will get back to you at Q&A time. Greg, you're going to come on in and tell us about visual tracing and debugging in Apigee.
Thank you,
Take it away.
So yes, so like Leo said, at some point you have your API and you may want to expose it to be consumed by developers and third parties, and that's the thing we will be exploring in this demo. So I'm introducing myself, Greg Reboul, working for Arctiq as a consultant. I'm focusing on everything DevOps, Kubernetes, microservices, and all the associated tools around that can make both the developer life easier and the system more reliable. So to talk about Apigee and how the configuration works from a developer standpoint, the first thing we need to understand is how the message processor is executing and treating a request. So as you can see here, on the left, you have an HTTP client. So it could be a mobile app, could be a web browser. And so this client does a request. This request will go through a series of flows. So you can see the two big groups. In red, you have proxy endpoint. Proxy endpoint is everything that relates to the query and how to format the query, authorize it. And at the bottom on the response side, how to format the response and maybe log the final, the end-to-end process in your central logging system. On the right side, you have the target endpoints related flows in blue. So those are in charge of maybe authenticating your API against the target API represented by the HTTP service on the right. So you can format the request, do some transformation, do some potential cleanup, and then on the response side, you can also format the request. Maybe you want to cache the response or those kind of things. At the bottom of the screen, you see the XML portion that represents how visually you will see those flow configured, and we'll go through them and create some of them to solve some business cases that I would introduce to you. And on the right, you can see a screenshot from the blocks. So you can see the policy blocks. So you can think of just Lego bricks that all have one function, and then they get plugged into those flows in the bottom section. So during this demo, what we'll be doing, we'll be creating a proxy from an open API specs. So that's something I will show you just in the next slide. We'll publish this API to the portal that is provided by Apigee. And as a developer, we'll be able to create our application and get an API key. And then we'll make some improvements to this proxy using the management GUI and the tracing tool, and we'll see the kind of stats and analytics we can obtain out of those tools. So OpenAPI. OpenAPI is not that new, but it's a way to describe your API and make it easy for the developer to consume. So when we'll be creating our proxy, we'll use an OpenAPI specification that is just a YAML file that describes every endpoint, the parameters, what are the URLs, and so on. If you start using that for your APIs, there's an entire ecosystem that will help you with automatic code generation, automatic SDK generation. You can also do some automated testing, mocking, and so on. And the best part, maybe you're already familiar with the previous version that was called Swagger. So by the way, OpenAPI is brought up by the Swagger company. You will have this interactive interface that you can publish. You will see that in the portal where you can test every endpoint. So what this spec looks like. So here you can see the one we'll be using for our example. So you see some general information and then a description of paths. So that's where you can see all the parameters as well, the type, description, and so on. So maybe just one word on the API I'm using as an example. It's called DataMuse. It's a funny API where you can use machine learning to search some words. So we'll play with that in a instant. So let me show you all of that. So the first thing, so DataMuse is this API. So we'll use that as an example. So it's a simple HTTP API that you can use behind this domain name. And you can, for example, find words related to duck that starts with the letter B. So in this case, you will have to use those keywords in your query string, and that will give you a result. So that's what we'll be using for our target API. And let's go to the Apigee interface. So you see we have two pre-existing proxy. We'll be creating a new one for this DataMuse. So I'm clicking the plus proxy button. And I will use an OpenAPI spec to create this reverse proxy. So I'm choosing the file here, drag and dropping the OpenAPI specification, and select. So here you see that we have 4 steps to create this API. The first one is to update the details. So I will change the name here, word search API. I already have the description from the OAS spec. And I will update the endpoint to hit api.datamuse.com. Going next. So here you will see that this basic DataMuse unauthentic API, I can just simply use a security in front of it. So I will pick a simpler API key. So this API key will allow us to identify the developer that is doing the call, and then that will allow me to enforce a quota per developer. So every developer has equal access to the resources. And I'm gonna add the course header as well if we want to call that in the browser. You can see here the path that has been taken automatically from the specification. And I will choose the Backstage Pass environment that we have created. Create and deploy, and now it's deploying. So just one word on this.
Greg,
Backstage.
quick question.
Yes.
So that BSP environment you had pre-created beforehand, right?
Absolutely. So those those represent the 2 clusters. This is what I will show you here. So we have an environment group that ties together the 2 clusters that Leo just showed us. So you can see the GCP cluster, and so the corresponding runtime will be accessible under this host name and an AWS cluster with a different domain name. Okay, so one of them is in Europe, the other one is in North America. In terms of use case, you can think of if you are developing a mobile app, you may want to have an API that is hosted close so you can have a fast response time. Now let's see the proxy we've just created and deployed. So I can find my word, I can see my word search API there with the status green. It has been deployed. And I have some traffic from before because during my test, I used the same name. So on the overview tab, we can see that the revision 1 has been deployed on BSP. You can see what the base path is and the target endpoint. So while I'm here, I'll show you quickly this develop panel. So the develop panel is a view of all those policies. So you can see the add course, impose quota, the remove API key, verify API key. Those have been generated automatically when I've created my proxy. And so those three, the verify API key, remove query, and impose quota, are on the pre-flow of the proxy side. And on the response of the target side, you can see that we are adding course header there. So now what I want to do is I would like to change the quota limit for the developers. So you can see in this XML file, you have a count, an interval, and a time unit. I can also edit that on the right side. So that way I'm sure I'm not messing up with the XML specification. Saving the version. So now we have revision 2. Okay, and I will deploy this new revision to BSP. Now, while this is running, what I will do is the next step, I will publish this API for a developer to be able to consume it. So I'm going to this publish API product section, clicking plus API, and now I can create my new product. Word search product, same for the display name. I will add a description. The environment it's running on. For access, I can make it either private, public, or internal only. So I want to make it visible only for developers who have access to this API. And I can write the quota here for information. I will link that to my proxy and save. Oops, we do have a conflict. Just retrying. So maybe, how can I do that? Okay, well, let's try to see if there's nothing there.
Greg, I wonder if maybe because we've been testing it for demos enough, maybe we just need to change some of the namings ever so slightly.
See, we have one. Maybe this has been submitted twice or something.
It could be.
Because see, it's already entered, so I can see the proxy. Okay, now let's see if I can publish that to our portal.
Looking good so far.
So this is a portal I've created just by doing plus portal, basically, and adding a couple of logos and names. And I will try to add my product to the catalog. So I'm clicking plus here, word search product. I can mark it as published here. I would say anyone can view that the API is present. I will select an image to illustrate my API. And I can select the specification here, the same that I used to create my proxy. Okay, so this has been saved. Now I will go to the portal. So this portal is provided by Apigee. So as soon as you just plus portal, you give the host name, and then you will have a portal like this. So you can see in the API, I need to sign in to view APIs. This is what I will do.
I may be partial, but I really like the logo choices and the color choices on this one. I don't know if you put that together on purpose.
Yes, it's not too bad. Okay, so
Very
you can
good.
see here in our catalog, we see our World API. So yeah, so last time maybe that was just a double submit, and maybe I double click, and that was bad. Okay, so you see the mock target API here, and we have this interface, this dynamic interface that could allow us to test the API with the different parameters. You can see their description. All of that has been generated automatically from the OpenAPI specs. So now, as a developer, if I want to consume this API, I will need an API key. So I need to create an application. So the application naming has some constraints. So I have to keep it lowercase here. I can add a quick description and enable the API. I'm creating this API, and you see that an API key has been generated for me. I'll copy that on my side, and you can see you can add, you have no expiration. You can add additional keys if you have other developers you want to share that with. Oh, I don't know why it's not created. And so the point is, I got my key. I will be able to use my API. So let's try something here. I will change the key with the new key I've created, and I will do a query. This query takes these parameters. So I want something from the lexical field of spoon that spells with A, that ends with an A later. And I want 10 results. So I'm going to try to call this. And you can see that I have my response. So I get spatula, pasta, salsa, polenta, tortilla, tuna, and so on. So the API works. This has been authenticated. So let's test without the authentication. If I'm not authenticated, you see that invalid API key and the 4.1 error is yelled. So API key. Now let's see if I can hit my quota. So 3 calls on AWS. Now I'll continue on GCP. The quota should be shared across 2 clusters.
Greg, are you using lunch items on purpose?
Oh yeah, sorry about that. I did that before lunch, and this is what I didn't mind.
Very good.
I'm so sorry. So here you see we have exceeded the quota. So rate limit quota violation. So as you can see, I've called from both data centers, but the quota is unique. So it has been shared in this central Cassandra ring. So now there's something that's a bit bothering me is you can see a 500 internal server error. And that's typically not what you want to show to your API consumer. So maybe we'll try to work on that to customize a bit the response. So to do so, I will go back to the proxy development interface. Okay. And develop panel, and then I will need a new policy. So this new block. So if I'm clicking plus, you can see that you have a lot of preset policies. So you have policies around traffic management, for example, the quota that has been automatically added. You have the spike arrest, so it's an anti-DDoS that you could use. You can also use some caching that will spare a bit your backend proxy. You can have a special URL to reset the quota. Around security, you have all those types of authentication with OpenAuth. You can do LDAP, you can do SAML, JOT tokens, HMAC. Then you have some other additional blocks. For example, you could convert to XML. That's something we'll see later, maybe if you have time. You can raise a fault. You can assign a message to change the response, and then
Greg,
you can write some custom scripts.
Greg,
Yes?
is it possible to add custom policies?
So you could use those extensions, so Java, Python, and JavaScript, that will allow you to write your own. But also you can customize those ones. So for example, for us, we want to customize this response in case of quota exceeded. So we'll use this assign message, and you will see how we can change it. So you can see by default you have all those preset parameters. So now to save time, I will just copy the one I worked on, and you see this send message that will be named quota custom message, and here you have a plain text message here that will be returned, a new HTTP status code, and reason phrase, and so that would be assigned to the response. So now I have this quota block. I need to integrate it into my flow. So I will go to the pre-flow, and I will add fault rules in the list of fault rule to show this message where the fault name is quota violation. So let's save this and deploy. So now if I'm going to overview, we'll see the status here that would show us where the deployment is at. So it's deploying the revision. And we'll have to wait a bit to get that working. So in the meantime, I can show you some other calls we can do with this API. So for example, oops, the API key, I need to change this API key. I can look for words that usually follow Apple. And if I'm running this, you can see I have a dot and trees, apple pie, apple computer, apple juice. And let's see where my deployment is at. So applying routing changes. So that we should be good. So now let's try to hit this API until I reach the quota. Yes, and now you see we have this text response and status 429, too many requests, which is better than a 500. Now I would like to show you another type of customization we could do. So without modifying this backend, what if we had some legacy clients who can only talk XML? So for example, you could say, maybe let's try to send an accept header application XML for the request and see how that works. Let me change the API key again. And here you can see, of course, that it doesn't work. So why is that not working? Let me show you that in the trace tool. So here I can open a tracing session running the same query on Postman. So this would be intercepted by the tool. And then you can see not acceptable. And where is this not acceptable coming from? So you can see all the blocks there. And by using those buttons or my keyboard arrows, I can go step by step.
It's almost like it's breaking apart the entire request into a visual way for you to debug it, right?
You see exactly what's going on, and you can see
Yeah.
the response received from the target server is not acceptable, right? That means this guy, so the data muse, doesn't want to speak XML. That's fine. We can do it for him, no problem. So what we'll be doing in this case, we have to remove this accept header before it hits the target proxy. So we'll be creating a new policy. So a policy that modifies the message is typically an assign message policy. And I will write this block. So you can see this assign message policy has two parts. The first part is assign a variable. So what I want to do here, I will store in my accept Apigee variable the value of the accept header. And I'm passing a default value application JSON. And then once this value is saved, I will just remove the header. And so the header will no longer hit the target proxy. So if I'm doing this, submitting, deploying, so we can see the status, it's deploying. So this is the synchronizer that runs on each cluster that gives us the feedback. Oh, it's deployed. Trace. Stop the session. Oh, you see our new message has not been called, so maybe let me check what the deployment is like, and I don't see. Oh yes, okay, I see. So the accept header interception has not been linked to any endpoint, so that what is not part of the flow. So I will have to add a new step in my flow, or I can do it on the right. Actually, it's probably better. Oops, no, I have to do that. A new step, and here I need to add the name. So I was thinking doing that in 2 steps, but in the interest of time, maybe I'll go directly to the next phase. So I will save this one, and then what that will do, that will remove the accept header. Now, something we need to do is on the response type, we need to make sure we convert the response from the endpoint. So that's a new block we'll be doing here. And we'll be converting the response from JSON to XML. So I'm just using that block. I can simplify it a lot because I don't need all those things. I can just say convert to XML the response. And now I need to integrate that in the target flow. So now in the target flow, I will add what we call a conditional flow that is between the pre-flow and the post-flow. And so this conditional flow, if the variable accept contains application XML, then we'll execute this extra step. Now let's save that. So now we can see, yes, we have all the steps, and in the response, we don't see the extra flow. Yeah, the extra flow is there. So it's saved, and let's deploy.
I'm sure for everyone watching that this is showing off how many more things you can do with your API that you might not already be doing. Right?
Absolutely.
I mean, there's lots of layers you put in there very swiftly without a lot of notice. So, yeah.
And also that, yeah, that's really allows you to make the most out of your old API. So it could work the other way, right? You could have a legacy API that only does XML, and then you want to modernize it. You will see with just this step, then you can convert it in a JSON-based API, which is kind of neat.
Right. Instead of outright rejecting XML, we can simply accept it and convert it.
Absolutely. And
Yeah.
you see you have all those preset blocks. So I will launch a new trace session and see. First, let's see if my old calls are still working. And yes, you can see the JSON are still working. And now if I'm trying a new call with application XML, then you can see that my response has been converted to XML. And now let's see how those calls are looking like. So on the response time, you will see the conditional flow that is there. You can see that the expression, the condition is accepts equals application XML, and here it has been evaluated to false. So that's why the flow has not been executed. And let's see this one, where the same condition has been evaluated to true, and therefore the convert to XML flow has been executed, and you see that costs us an extra 2 milliseconds. So that's really nothing compared to rewriting the entire application. So what we've seen here is how you can use this trace tool. You can visually develop with all the hints given by the pre-canned proxies here. And what we can see, you also have a performance tab where you can follow exactly what the traffic is like. There's the last thing I would like to show you is in Analyze, you can see some very interesting metrics as an API producer. So now you have published your API, you may want to know who is using what, who is your best developer, your top user, and then you can engage with your community. And here you see you have those stats showing you who is actually using your API. And then you have some details, so you have some app names. Think of mobile app, you will see which mobile app is using the most your API, and that's a good way to focus on the errors that really matters, or how to improve your SLAs and so on.
It's
So that's from
interesting. In some of these graphs, we're kind of foreshadowing the auto-scaling piece coming up. So I hope everyone's excited for that.
Absolutely. And then you have some end user as well metrics where you can see where your final user, the user of the app of your users, where they're coming from, what devices they're running, and so on. So you have all those stats coming with Apigee. So yep, that's it for me for now. I hope you liked the demo. And Aaron, back to you.
Thanks, Greg. That looked really good, and we have probably a whole bunch of stuff to talk about as a result of what you showed off. So I'm gonna drop you out, give you a break, and I'm gonna bring in Aurora.
Hi, Aaron.
Hey, Aurora. So it looks like you're going to talk to us about Apigee Hybrid Autoscaling.
Yes, exactly. So after Leo talked about the architecture and some architecture decisions, and after Greg from the developer team's perspective talking about how you can use Apigee platform for your development work, I'm going to focus a little bit more on the operations side, where I'm going to talk about Apigee Hybrid Autoscaling. All right, so a little bit about myself. I mainly focus on things like networking, cloud infrastructure, and Kubernetes platforms. And I'm working at Arctiq as a consultant. I also help a lot of enterprise customers to enable their Anthos platforms and some other different infrastructure they're using. All right, let's dive right in. So Leo talked a little bit about Apigee Hybrid components already, but here I just want to highlight a few things. So what we are focusing on right now is the runtime plane, which will reside in your own infrastructure. It can be in GCP cloud, it can be AWS cloud, or it can be your on-prem data center as well. And this piece will be running inside the data center of your choice. And this should look very like other microservices you're seeing. So there are different components that's running this Apigee runtime, including Cassandra, like data store, and runtime, which is the message processor, and also logging, monitoring, and synchronizer, et cetera, et cetera. And with microservice architecture, there are a lot of benefits of it, including when you're deploying, for example, a new version of your APIs. Instead of having a downtime, you can probably roll it out using some technologies like canary release. You can choose to route part of your traffic to the previous version first, and then to the rollout to the newer version. So a lot of flexibility here with microservice architecture. And what we will be focusing on today is the runtime piece. So I'll be doing some auto-scaling demos around how you can scale up, how you can see the scaling up of your runtime ingress, and also the runtime message processor for Apigee. All right, and with all these components, some people might be worried about all the configurations they have to do. For example, for Cassandra, how much memory I have to allocate to that service, and for like runtime, how much CPU I should allocate to that. You can definitely tailor those configurations. And from Arctiq's perspective, we also have helped different customers with the sizing of each components as well. But luckily, Apigee has also provided us some pre-canned solutions for us as well. That's what I'm going to talk about the 3 t-shirt size deployment. So you can choose, when you're deploying your runtime to your own infrastructure, you can choose to have a very small deployment where you only have a very basic runtime and a single data store to store all the persistent data you need. And in that case, it might be your developers' environment where you don't really care about uptime as long as they have some access. The developers have some access to your APIs, you should be fine. There's also a medium-sized deployment as well, where you can see you have 2 data stores as a high availability pair, and you also have a few more bigger and larger runtimes to handle all the requests. So this can be, the use case can be you have an internal API platform for your internal use, but it doesn't really matter if it's down for a little bit as long as the availability is at 99%. That's probably good enough for you. So you can choose this medium-sized deployment. And there's also a large-sized deployment where this is probably your production environment, where you really have to make sure your API platform is up all time, where you have a larger data store, and similarly for runtimes. And all these also applies to the other components as well, but here I'm focusing a little bit more just on the data store and runtime. So depending on your use case, you can choose from the 3 pre-canned solutions that's offered by Apigee for your runtime deployment. And this really matters because you really want to have the best usage of your infrastructure. So if you only need a small deployment, you really do not have to reserve all those resources inside your data center or in the cloud. You do not have to pay for extra resource if you do not need that. Having said that, although we do have 3 fixed deployment, there might be sometimes you will receive a little bit more than what you expected. And that is where autoscaling will come in and help you. And I'll explain a little bit about what I'm going to demo. So regularly, there will be traffic coming into your Apigee components. So we do have ingress gateway and Apigee runtime, which is handling all the API calls. And to support these Apigee components, you also have Anthos cluster components, which are mostly VMs, so Anthos nodes. So on a regular day, you have, let's say, 2 ingress gateways and 2 Apigee runtime. That's more than enough for your regular traffic. And you also have 2 Anthos nodes that's supporting the whole Apigee runtime platform. But suddenly, there comes a large load of traffic coming in to hit your Apigee, your API service. And your existing Apigee component cannot handle it anymore. But luckily, since it's a microservice architecture and it's using Kubernetes as the orchestrator, it can detect the CPU usage of each component or each pod of your Apigee runtime. And if it's seeing an overload, it will actually spin up more ingress gateway pods and more Apigee runtime pods to help you to handle the load so that your APIs can still be up for your users. And similarly, on the Anthos side, because it is a Kubernetes cluster, and it's an Anthos GKE cluster, it also has some auto-scaling capabilities. So if right now you only have 2 nodes to run all of your Apigee component, right now you have more workloads, so you will need a little bit more CPU and memory resource. Here, the Anthos component will also do auto-scaling for you. So in this case, although you do have larger than usual traffic, because we do have auto-scaling capability on both the Apigee side and the Anthos component side. From the operations perspective, you do not have to do anything really. It will be scaling up automatically, and it will make sure the traffic is handled. And when the load goes down, all these components will also be able to scale down as well, just to help you with cost saving. All right, so this is an overview of what I'm going to show for my demo. And let's move to the other screen. So for today's demo, I'm going to use a load test tool called Autoscaling. This is basically an NPM tool, which you can use. Here, I'm sending 2 concurrent connectivity requests to this Autoscaling API proxy that Greg accidentally showed you already. And we'll see how the performance goes. And then I'll increase the load and see how our runtime, Apigee runtime will react to that. All right, so let's see what's going on here. So here I'm monitoring what's going on with my Apigee runtime. Here you can see I did some pre-configuration before the demo already. So here on the runtime side, I'm setting up saying the maximum pod number or the maximum instance of runtime. It's 20. So in case of a large load, I can at max scale up to 20 different pods, and the minimum is 1. It will also show us the current CPU of what we have right now, and also the target CPU, meaning if the current CPU reach 50%, it will try to scale up. And here we can also see some status of our cluster as well, including the desired pod and the current pod. Similarly, we'll see the same behavior on the ECO ingress gateway because it's taking in the traffic before it hits the runtime. All right. And in the other window, I will also start watching our Kubernetes, our GKE components. So here right now we do have 6 different GKE nodes. And if needed, we will see another node popping up here. All right, so let's try with some light traffic first. So here it will send 2 requests every time, and it will last for 2 minutes. Actually, let me shrink it down to 10 seconds so we can see some behaviors, hopefully. Yeah, so you can see the CPU changed a little bit because our load is pretty low. So right now what we have on the Apigee components piece is able to handle that traffic. So there's no need to scale up. But if we try to add more traffic here, let's say we want to do 2,000 requests at the same time, and we do it for 2 minutes. Let's see what will happen.
This is where the fun of working in the cloud comes into play.
Exactly. No one will call you saying what you're doing here. But as you can see, the current CPU percentage has jumped to 400% here. And also for Apigee runtime, it jumped to 200%. So now the desired pod, instead of the one we saw earlier, it's 4. And now our cluster is trying to scale up. And you can see the current pod also changed here. But after changing it to 4, it still cannot handle the traffic. So it will still scale up. And just checking on the node, we're still okay here. Yeah, it's still trying to scale up. because I set the target CPU to 50% because of our load. It's a lot more than 50%, so it's still trying to scale up. And unfortunately here, it's already reaching the max, although we are still having a very high CPU. There's nothing much we can do. And of course, this will be a limitation to our load test. There will be some failures because the ingress gateway has hit its maximum.
So Aurora, I think I need to ask because someone might be wondering, is this the type of thing where you would advise people handle the scale of their gateways in a static manner, or is it definitely where you'd want to point them towards using HPAs?
Yeah, definitely. I can think of some use cases where HPA can really help with your environment's health. For example, let's say you have a small deployment which is only used for your dev team. Usually, there will not be a lot of traffic from your developers trying to hit your APIs. But maybe there's some deadlines they have to meet, and they have to really work hard on one single day. So they decide to do all their development, all their tests on one day, and they really have to rush through it. And if you have HPA and autoscaling enabled, you really do not have to worry about this. You can let your developers do their own thing. And also, after they meet their requirement, after the deadline, your environment can scale down as well, so that it can, from operations perspective, the cost will not be significant. All right. Cool. Yep. That's all the load that's running, and you can see here we already scaled to pretty much the maximum here to handle all the traffic I was trying to load to our system. All right, so with this auto scaling enabled, as you can see, we do have a lot of requests. And in order to handle that, we do have auto scaling of some components of the Apigee. And fortunately, with that enabled, we only have 900 errors. And usually, this is because we do have a still ingress gateway maximum set. And also, when it's scaling up, sometimes it will take some time. So here you can do some fine tuning in your own environment to see what's the best fit for yourself. And for example, at the minimum, I have only one pod for the runtime. In your case, you might need a little bit more than that. All right, and just quickly, I want to show you what you can see from the Apigee dashboard. So here you can see a lot of the performance data being collected here. And we're doing auto scaling. So you can see for the 2 minutes, we have a lot of traffic coming in. And you can also see the average response time, what kind of traffic that's hitting it. And there are a lot of different things you can see here as well from the operations perspective, including latency. We have to set this for response time, target response time, etc., etc. And one thing I really like about Apigee Hybrid is you can also set alerts so that from operations perspective, you will receive some information when you are seeing a lot of traffic hitting your runtime, or if you're seeing any delays for that. So I won't go through this because I see we don't have 15 minutes left, and I want to leave more time for Q&A for sure. But yeah, that is it. And hopefully my pods will scale down sooner than later so I can save some money. Back to you, Aaron.
Thank you, Aurora. That was also really good. And now that we've covered multi-cloud, visual tracing debugging, auto-scaling, we can get into our Q&A session. And you guys might even meet our special guest pretty soon. So again, that was really good. I'm going to bring back Leo and Greg, and I'm going to bring in our special guest, Greg. So now we have two Gregs. Oh boy. Greg, say hello.
Yeah, so absolutely. Thanks, everyone. That was a fantastic presentation by everyone. I think maybe even I learned some stuff as I listened along there. And I'll also say that this isn't the first time that I've worked with Greg. We've been on multiple calls with customers together before. It's not very often that I've got another Greg on the call, but it can be confusing sometimes.
Yeah, what we did is we scaled up the Greg What replicas to 2 today.
Right.
It's looking good. I know that you guys are, you have your unique contributions though, so you're not stateless, you're definitely stateful. So yeah, this is good. We do have a few questions that I wanted to cover. Some of them we have a list from the team, some of them from social media, but there's a few that I wanted to get to. One of them was for Leo. Are there already some use cases where multi-cloud architecture of Apigee Hybrid does make sense right now? Because I know it's new, and that's, I guess, why the question is worth asking at this point.
That's a great question. I mean, the easy answer to that is just fighting entropy. But just to go into it, your organization, if it's already going down the path of a multi-cloud strategy, it's thinking along the lines of data governance, GDPR. It wants to be closer to maybe your users or your API consumers. They want to reduce the latency. They want to have cost control and have access to more different feature sets that different clouds offer. And Apigee Hybrid does a very good job of coming in there and aligning very clearly with the corporate's multi-cloud strategy. And it helps you develop and manage all these APIs as you take your monoliths and you break them down into smaller components. So the entropy that I'm referring to is that as that it's being broken down or you're developing new APIs, it's being sprawled all across and it's scaling and your organization is also increasing in size. As Jay-Z says, more money, more problems, kind of like that, you know? So in another way to explain it is once you get to that scale where your organization has more problems and you have multi-clouds, you have a multi-cloud strategy to address all these different people in different areas of the globe, your procedures have also matured. Your relationships with the people that are consuming your APIs, the developers and the API providers, they've become a lot more formalized. It's not like, hey, Jack, down the aisle, what's the API key over here? So that communication reduces that friction. Also, you have a lot more needs when it comes to like mediation and orchestration of your APIs across all these different clouds. And we have it now in like AKS. I had no idea we had this API there. Now we need access to this. And there's also an increased focus on APIs at that scale. It's no longer, APIs are no longer like an object that a technical team deals with. At that scale, you have business units that are someone from accounting, an executive in accounting goes, hey, we have access to an API to the inventory. Instead of us sending these reports to this customer, I want to make this a product so their systems can just talk to our systems and I don't have to do that anymore. So all of a sudden, different business units, executives that are completely non-technical are talking about APIs, are trying to utilize APIs. And to be able to manage all of this across this now globally, and soon it's going to be like universe scale, the way the path is going, you need something like Apigee Hybrid to be able to keep it together, just like Anthos is there to keep it together when all your Kubernetes clusters are across all these multiple clouds. That's why they play so very well together and they're very well aligned. I hope that answers the question.
Yeah, that works. I think it's clear like people are starting to rely on APIs now outside of just the dev department, and it's much more prolific, I think. So I guess timing wise, it's a really good concept to bring to light. And just for everyone else, feel free to jump in on any of the questions we have. I'm pretty sure we're safe to cross over the 2:30 mark, considering the density of topics we covered today. I got one for Greg Kuelgen. Do the services managed by Apigee Hybrid need to be running on Anthos?
That's a great question, and I get that question from time to time. So Anthos itself is, of course, a platform. It's a suite of tools. It's not any one thing. It's really designed to allow enterprises to modernize their application stack. Apigee Hybrid runs on Anthos basically in order to provide sort of a seamless and supported experiences for operators of Apigee Hybrid, regardless of where they deploy that runtime. And even in the great example that you had a runtime in AWS and you had a runtime in GCP. And we want to provide that consistent experience that is happening across of that. So the question then becomes, do these things need to be running on Anthos? And the answer is no. While Google would certainly love to have all of your workloads running in Anthos, Apigee Hybrid can manage workloads regardless of wherever they run. So it doesn't matter where that API is hosted. Apigee can provide API management for that API.
Sounds good. Very good. Thank you. I've got another one for Greg. In your experience, and we've had a few engagements so far with customers, and plus the ones that you've done without our knowledge, what have been some of the key features that customers are trying to get the most out of with hybrid?
First of all, I think, Leo, you did a fantastic job of kind of explaining why multi-cloud and how this is working. And I think that's just the reality of where our customers are today, right? We've got customers, most of these enterprises, they've got newer technology, they've got some older technology, they've got a mix of workloads, they're generally got some on-prem workloads, and for the most part have more than one cloud provider workloads for there as well. And so, from a SaaS perspective, we may not be able to meet all of their requirements, a little bit what you all talked about at the beginning. They may have specific security requirements or specific latency requirements that they're trying to meet. And so hybrid really comes in and allows them to position that the runtime as close as possible to their workload. And the other thing that I'll just, again, to go and reiterate a little bit what you were saying, Leo, is that this ability to have a single management plane, no matter where your runtime is, and be able to have a single place to do governance across all of your APIs is really important. And I think it appeals to developers, it appeals to operators that are operating the platform, and it appeals to security folks and folks that are tasked with actually governing access to the APIs and things like that.
I'd like to add to that, if you noticed what Greg did, one API was talking in XML, and he was able to quickly convert that and transform that on the spot. That means that gives you a certain agility that you don't have to go find out who is the dev team. Are they even employed at this company? Is there documentation? Can I engage them? Can they go ahead and change this for me so now it speaks in XML to JSON or so forth and so on? I'm not even talking security. I'm just talking basic transformations. Just that happens like this now with Apigee Hybrid. And with Apigee as well. And that level of agility is what I'm talking about as everyone's coming in and saying, now I want access to this API. You can give it to them in a day, not 2 months down the line.
Yeah, absolutely. Good point, Leo.
That's a good one. Another one that just sort of is interesting, because I know many of us come from an infrastructure background, and someone asked it sort of during Aurora's, but I mean, you can answer it. Anyone else can chime in. But does control of Apigee and its infrastructure? I mean, yes, its infrastructure belongs with the ops team or the infra team, but does Apigee belong in the hands of an infra team, a DevOps team? Should it be focused on the operations team? Like, where should it sit, in your opinion?
Yeah, that's a very good question. I'll be honest. I think my answer will be it depends. So it depends on your enterprise organization architecture. It will depends on how you want to facilitate all the functionalities for this. But from my perspective, usually what I see from Apigee engagement and also Anthos engagement is we treat the infrastructure as a platform. And we treat Apigee as an application running on top of the platform. So this might give you some ideas when you're doing some races with inside of your organization, how you want to organize who's responsible for what. And yeah, again, it really depends on how you want to manage this platform for sure. And I'm not sure if everyone else want to jump in here.
So I think you're right, Aurora, and I love the fact that you I say that's my favorite answer as an architect is it depends. It seems that's what we always come back to. I think that's right. I think in practice, what we've seen is there's oftentimes sort of a centralized team that's a Center for Enablement maybe that has some responsibility for the platform, and then they generally, of course, are working with some lower level infrastructure teams as well in support of it.
Absolutely. There's another one for Greg about the Apigee GUI, because you were going through it quite a bit during your demo. Is it the case where you want to give this to a team and have them use the GUI, or is there other ways to interact with it? Like, do we want to use other languages like Terraform and Ansible to GitOps this thing into its configuration, or would you say it's better to do it from the GUI? Like, is there different approaches to it?
So same answer, it depends.
Yeah.
So
fair enough.
By default, so this GUI is managing all the versions. So in terms of versioning, you will always be able to go back. So in this case, using Git will not really be a big addition because you already have all those things. Also, each package, each revision contains the XML, the definition of the entire proxy. And if you add additional JavaScript files or Python files, they will also be part of the package. So they are stored in Google Cloud so that you won't lose them. So if you have one person in charge of all your APIs and you want to coordinate, you can use the GUI. Now, if you have multiple teams, you can also decide to centralize all your code in a Git repository, and as we've done for a customer, build a pipeline that will package automatically your proxy definitions and then send them to the server for deployment. So you can really you already have those options. So now you can also have an hybrid of both. Even if you are using a pipeline to deploy your code, you will still be able to go to the GUI and see visually all the policies that are in place and all those flows. Right? It's really it's not exclusive.
Sounds good. That's fair. I guess in a lot of these cases it depends because we're laying a layer in front of something that might have some legacy tied to it, right? So whether they move into different tools or not is also another question.
But definitely using the tracing tool, the one I showed you, is something I will do no matter what, because it's really great. You can see step by step the state of every request after or before transformation. You see exactly the evaluation of all your expressions, all your conditions. So because you've seen the flows can be a bit complicated, having this visual tool really greatly helps knowing what is going on. So
for
this
sure,
one I will keep in all cases.
Oh, for sure, yeah. It's much better than trying to put something like a TCP dump in between you and the thing and figuring out where it's going wrong. And yeah, visual tracing is nice. This one's for Mr. Kuelgen. As you have been working with hybrid customers, do you see a benefit to engaging a partner for their hybrid journey? Now, I know this one kind of points to us, and I kind of like that, but tell us about it.
So it does point at you a bit, and not just you. And I've worked with quite a few customers on their hybrid journey now. And the way I look at this is, Apigee Hybrid is a pretty modern platform, and it's making use of pretty modern platform technologies as well, right? We showed there, you all showed that really well today, right? With your autoscaling that you did, and you're showing Kubernetes under the covers, and the HPA, and all of these things. And oftentimes the teams that are most interested in Apigee have a lot on their plate already. They're trying to digitize the company's assets. They're trying to grow the API program. they may not be super familiar with a lot of these underlying technologies in particular. And while certainly they can come up to speed on these things, what I've found is that having a partner there that understands all of these things can really help speed that first business outcome delivery and smooth speed bumps along the road. And I've actually seen it time and time again and help to kind of jumpstart the program and bring the teams up to speed as well, right? Because it's not just about the partner doing everything, but it's about knowledge transfer and the knowledge that you all bring from doing this at multiple customers and things like that. And it's just really been valuable, I think, to have partners engaged.
Thank you. Does anyone else want to add to that? I mean, we have spent some time with Apigee now, and I think the team is showing with the demos alone that we like to kick the tires in this thing pretty well. Nothing else?
Yes, I would say also the role of a partner in this case is to adapt and make the adoption more specific, right? Because we've worked with different type of customers and they have different level of compliance required. You can work on custom flows or global flows for all the security. You may have also some constraints in terms of private networks, private data, and for all of that, it's always easier to have a guide, right, in your journey. So that's the role we are feeling there.
Very good.
Yeah.
This is another good one that I think it probably works well towards the community, and anyone can jump in. Is Anthos required and is ASM required to make this happen if someone wants to just kick the tires?
So I can take that.
Sure.
ASM is required, even if you just want to kick the tires. The easiest way to kick the tires on this, if that's what you want to do, is to do it on GCP with GKE. You can follow along in the instructions. The instructions walk you through how to set up a trial org. You provision all of those things. You follow the steps along. It's pretty straightforward, and you can get yourself up and running just to kick the tires pretty easily. But it does require the use of Anthos and ASM in particular.
Very good. Seeing as how I guess you can land this on other clouds because of Anthos, and you're running GKE there, you probably just may as well take advantage of ASM at that point, right? I mean, someone might try and plug in Istio for sure at some point, and then see, whatever shortfalls they may happen to run into.
Sure. I mean, ASM is Istio under the covers, but we use some specific features for ASM. And then part of the reason also that we choose ASM or Anthos Service Mesh, to clarify for anyone that doesn't know what that is we want to be able to provide supportability as well, right? Istio is open source, whereas Anthos Service Mesh is fully supported by Google.
Yep, absolutely. Support's important. I have another one for Greg K, and this one's for someone who seems a little excited, so to speak. Are there any specific features someone should be excited about when looking at Apigee?
It's a good question, and honestly, so the things that you demoed when you talk, so I'm not going to talk specifically just about Apigee. There's lots of great things about Apigee. I'm going to talk also particularly about Apigee Hybrid, a little bit of a mix. But you all demoed some pretty awesome things, right? That it's easy to forget how seamless it really worked. So you had multiple regions deployed, right? You had one in the EU that was on AWS. You had one in the North America that was on GCP. That was all hooked up to a single management plane. When you were deploying and you were adding those products, it was going and communicating across those clusters, right? You had no concern of where that was actually running from a management perspective. So that's one thing. The other thing, of course, is the scaling and the auto scaling. And Aurora, you just did a fantastic job showing how that all worked. And the one point I want to add there as well is that you can, we've got retailers, a lot of retailers, and sometimes retailers will have big launches, right? And that launch will happen at midnight on a certain day. And so you don't have to only rely on the HPA. You can go in and say, hey, scale me up because I know I'm going to get a wall of traffic at midnight, and I don't have time to wait for it to scale. So you've got that level of control that you can do. And then finally, I'm a sucker for the trace tool. And you kind of saw how cool that was. And Apigee's had that trace tool feature for a long time. But with Hybrid, we've enhanced it quite a bit, where you can now put a bunch of filters in place. And so let's say you've got some really troublesome issue that's been difficult to track down. You can put filters in place to say, hey, I want only this status code and this error come across. When you do that, then capture that particular trace and ignore the rest. And it really helps you to kind of find, hey, what is that issue that's going on? Why am I seeing that error sometimes and not other times?
Absolutely. And then, it looks like that's it there. And chat has no further questions. Anyone on chat, if you want to throw something in there, go ahead. Keep in mind there might be a few seconds delay between when you put it in and when we see it. But otherwise, I just wanted to bring in the kind of like I want to summarize this in some way. So kind of speaking to what we have here, I think these points point out some of the things that might be key for someone saying, what is this giving me? What is even just throwing in an API gateway in general going to give me? And I think some of these things speak to many of our customer cases or potential cases. Things like solving for authentication. If you don't already have that, this is a layer that throws it in there. Solving for security from a simple encryption level with TLS. From a security perspective, you get DR with the hybrid model, so you can go cross-region, cross-zone. Does anyone want to talk about, concepts of going cross-region versus cross-availability zone with hybrid? Benefits, pros, cons?
Yes, I would say maybe.
Yeah.
So cross-zone is more for HA, right? High availability. If you are concerned that a zone can go down, that's typically what you will use. You can also use a different system of active and active failover kind of setup. That's what I would use for the cross-zone. And cross-region is more, yes, you want to be local to where your backend proxy is or where your consumer is. You may have some constraint like the GDPR in Europe or those kind of things that will force you to operate in specific region, but you still want to have a global control plane, global stats, and so on. So I think those would be the two big cases, yeah.
Yep. And then the one that I wanted to point out that Greg showed off pretty well that you could see based on the policy layouts is the pre and post automation around how your API is consumed. This is a layer that I'm sure many existing or legacy APIs have trouble implementing. And so throwing it in as simply as Greg showed it off was really nice. Region-aware API gateways as a result of hybrid is also a nice piece. So if you are already hybrid cloud or multi-cloud deployed with whatever your backend services are, you can have a region-aware API gateway in effect. Scalable endpoint proximity for your API performance alone is a nice way to accommodate for Valentine's Day, which I've been told is sometimes higher traffic in one smaller amount of time than even the holiday season. Can you believe that? So, and then the last piece, co-locating your API proxy with your backend services and APIs is another sort of performance boom and another huge benefit to the platform. So I think we covered it all. What do you guys think? Is there anything else we need to talk about today?
I think we've covered a lot of topics today, so quite happy about that.
All right, very good. Anything else to say? I guess not. Thanks everyone for joining us. This has been another fantastic and probably a little bit like drinking from a fire hose kind of Backstage Pass for some people, and it's been really good. So please, while this is a live stream, we're going to keep this on our channel, but please like, subscribe to get notified the next time we do a Backstage Pass or any of the other events that Arctiq happens to do. And anything else related to Google, we have lots of content on our website at arctiq.ca. And beyond that, everyone say goodbye and have a great day.
Thank you, Aaron.
Have a good one.
Bye.